On to question number 10. Okay, so our final question for this session, question number 10. Okay, how to solve equations with infinite solutions or no solutions. So let's go through what the Junior Tutor explained here, and then we'll outline how to kind of conceptually think about this and how to use it to solve equations. So there's two situations, infinite solutions or no solutions. The third situation actually is one solution, but we're only focusing on these two. So solving an equation means getting a value for x. A solution to an equation is a number that can be plugged in for the variable that makes the number statement true. Excuse me. Okay, so here they show the first example, infinite solutions. They have, I'm kind of just skimming through this to give you kind of the most important stuff of this answer. So y equals 2x plus 1 and negative 4x plus 2y equals 2. So we want to find the solution for these two equations over here. So we set them, we rearrange this equation, and then we set them equal to each other, and we get 2x plus 1 is equal to 2x plus 1. And we can see that the plot they drew out, it's two lines overlapping each other. So 2x plus 1 is this line, let's say, and then there's another line on top of it, but it's not really visible. And that's where you get infinite solutions. And then in the no solutions example, they outline this equation and this equation, and plugging them in, you end up with no solutions and you get two parallel lines. So let's just go through the first example. So if we're given y is equal to 2x plus 1, and we're given negative 4x plus 2y equals 2. So we'll rearrange for this equation first. So we'll say 2y equals 2 plus 4x, and y equals 2x plus 1. So we can see that this equation is identical to this equation. So if we set them equal to each other, we end up with 2x plus 1 equals to 2x plus 1. You could also say that 0 equals 0 if you kind of just subtracted 2x plus 1 from each situation. So this is another indication where you have an infinite number of solutions. So maybe it's a different algebraic equation and you're just solving through. But if you see also 0 equals 0, that is another indication that it's an infinite number of solutions. And essentially what this means is as follows. So let me get some space for this. So if we were to draw out the plot, what does this mean? So we have some line, let's say our first equation, which is this, y equals 2x plus 1. Let's draw this in green. It'll be something like this. This is a straight line. And then our next one, let's draw this in blue. So we drew 2x plus 1. It's essentially 2x plus 1 again. So it will be the same line on top of each other. So I haven't drawn these exactly on top of each other, but they should be exactly on top of each other. That's why you have an infinite number of solutions. And that's kind of an explanation of what that means. And then it's the situation where you have both sides of the equation equal to each other, or when you have 0 equals to 0, and you'll end up with an infinite number of solutions. Okay, so I'll go through also the situation that is not outlined in this question, which is one solution, and what does that look like before going to explain the next situation, which is no solution. So we know that one solution looks something like this. So we have line A, which is something like this, and then we have line B, which could be something like this. And our solution is over here. So the point where the two lines cross is our solution. So that's the second scenario. And then finally, the last scenario. So the last scenario. So I'll go through over here. So we have two equations. The first equation, y equals to 2x plus 1. And the second equation, negative 2x plus y equals 2. First thing you want to do is get it into the format of y equals mx plus b. So we'll move the negative 2x to the other side, and we'll have positive 2x plus 2. So here we just added 2x to both sides of the equation to end up with this. And then we set the two equations equal to one another. So we set 2x plus 1 equals 2x plus 2. 2x plus 1 equals to 2x plus 2. And right away we can see that this is not true. So whenever you have two sides of the equation, they're not equal. So if we took out the two x's, we'd have 1 equals to 2. And that just doesn't make any sense. So whenever you have in a situation where both sides of the equal sign are not equivalent to each other, so this is not equal. I'll just draw a line through this. We know that it's a situation where there's no solutions, and it's the two parallel line situation. So I'm just going to draw this out real quickly. So this situation is as follows. So we'll draw the plot, and our first line will be something like this, and our second line, I'll draw this in blue, will be something like this. And then these two are parallel. I've drawn these a little off, but they are 100% parallel. If they were not parallel, they would cross each other at some point, and you'd end up with the second scenario, which is one solution. But we know that in the no solutions case, they're parallel, and therefore we end up with no solutions. The two lines don't cross each other. And that's kind of an explanation of what this means. So here they give you a short answer. Infinite solutions to a problem means all the numbers are our solutions. Most of the time, the solution ends when both sides of the equation are equal to each other, which means equations belong to the same line. On the other hand, equations without solutions do not have answers. The variable usually cancels in the solution. Also, the equations are actually parallel lines. So this is the correct explanation. We verified it and went through the step-by-step explanation. Correct explanation and answer. Great job. Okay, we'll mark this as correct. So that was our final answer. Okay, so thanks for tuning in. Hope you found that those math problems were helpful. If you need any more homework help or tutoring needs, you can always go on OneClass.com. You can always subscribe to this YouTube channel to see more videos like this and answering different math problems and so on. And you can also visit the link in the description. Hope you enjoyed, and I'll see you in the next session. Goodbye for now.